Welcome to Machine Learning Lesson 4.8. In this video, we're going to discuss another classification model, the decision tree, and see how it differs from the k-nearest neighbor classification model that was covered in the previous lesson. In doing this, we're going to explore the Titanic dataset again. So let's get to it. To appreciate a little bit of how the decision tree classification model works, let's explore this simple simulation of will you get an A on the next test? So this becomes the first kind of like decision as to, which way do you want to go? Now, the first thing that you have to see is what is your current average? So I'm going to go this route. Let's say my current average is a C. So now that's taken us down this route, which now requires us to answer a couple more questions. In this case, it's asking us, do we plan to cheat on the next test? And you kind of see that before we even answers, if we choose no, then the answer is no, we will not get an A on the next test. Let's go ahead and answer yes, which now takes us down a different path. And now we have how many hours do we plan to sleep in preparation for this exam. Now, from the tree, we can see that if we sleep greater than 8, between 5 and 8, we're good to go. If we sleep anything less than 5, doesn't matter if we slept, it doesn't matter if we're cheating, the machine or this particular decision tree has decided that we will not be able to pass the exam. So let's see, let's answer that last one. And we'll do it with less than 5. So hours slept. So let's say less than 5. And sure enough, you see there, we will not get an A on the next exam. And this, in a nutshell, is how a decision tree works. You have a series of decisions that are made that will take you down different paths to ultimately answer the question whether, in this case, whether we're going to get an A or not. So how does the program do this? How does the machine learning model accomplish this series of if statements? Because you don't actually program these if statements. The model develops these decisions itself. So for that, we have to go back to our presentation. And there's something called Gini, which is a statistical measure where it's the probability of the outcome. And the machine, based off of the data that is provided, decides which decisions will allow it to kind of divvy up the data in order to make appropriate decisions. Now, on the left side, you'll see that here's a data set where it's not clearly all, greater than 3, less than 3. It's kind of split up. You can see here a couple of people were greater than 3 that did pass, and a couple of people were less than 3 that didn't pass or didn't get the A. Same thing here, the opposite. The machine learning algorithm looks to produce these types of scenarios as compared to these, which seem more absolute. These absolute scenarios where it divvies up the data in such a way where it clearly says that all these people got the A and all these people did not get the A, though it might seem at face value to be the goal, to be able to get absolute values, but when it turns out to, in the machine model, it's actually not effective to do that. It's better to get these types of models that have some flexibility for the machine to be able to decide one way or the other. Again, we'll talk more about this at the end when we actually run through our machine learning model using a decision tree classifier. So let's head over to our programming example. And as mentioned before, we're using the Titanic dataset. And if you haven't had a chance to look at Machine Learning Lesson 4.7, the Titanic dataset has data from passengers that were on the Titanic. We have a column called survive, which states whether the passenger survived, what class they were in, whether it was third class, first class, second class, essentially below water level, at water level, or above water level. We have sex, age, and a couple of other features that could be used in our classification. So again, kind of going through the steps, what do we want to predict? Well, we want to predict if we would have survived the Titanic. We do a little bit of analysis using our standard features such as describe. Again, I'm going to gloss over some of these a little quicker so we can actually get to the machine learning part. Again, these are things that have been covered in previous videos. Looking at the correlation, we can see here that correlated with survived P-class, where you were on the boat had a big impact if you survived. And if you kind of imagine, that has to be the case. Another important feature that lent itself to survivability was how old you were. Going through, we kind of check through if we have any dirty data. So we do have some NANs in our age, so we're taking the approach of simply filling those in with the average of that particular column, and we're leaving it like that. In order to use sex as one of our predictors, we're converting the male-female into ones and zeros using the apply function of a data frame. And as you can see here, we have now converted the sex from male-female to zeros and ones, allowing us to use it as part of our feature to train our data, train our model. Going through to step 4, again, we've chosen these features, sex, age, and P-class. And just for comparison, again, if you have seen Machine Lesson 4.7, which discussed about the k-nearest neighbor, you'll notice that we don't split up the P-class into separate columns. Reason being that the decision tree classifier does not use distance as its measure of proximity. So it's okay for us to leave the P-class intact because it's just going to make a decision one way or the other. It's not measuring a distance, which inherently produces a bias when you have categorical information inside the same column. Again, that's a big mouthful. If some of this went over your head, that's okay. Just realize we're using the P-class as it is. Our target is whether we survived or not. And this next step is pretty much the standard thing that you do in most machine learning algorithms, which is simply to split that data into training and testing. The next stage is the first place where we're seeing something different. So again, in this video, we're discussing the decision tree classifier. But once we've created that object, the next step is identical, which is simply to train the model using the fit function and the training data that was split up from train test split. All right, after that, we got to see, is our model successful in predicting our target of survivability? And it produced a 0.82, which is pretty good. Now, I have pulled up the k-nearest neighbor example. Again, just to prove to you that this is the k-nearest neighbor classifier from Machine Lesson 4.7, you'll see that we got a score of 0.83. So they're not identical, but they're in the same ballpark. Again, two different ways of classifying things. The k-nearest neighbor used the distance formula between features to figure out likeness, whereas the decision tree used a series of decisions to determine data point's likeness to something else. And again, we'll see that a little bit more towards the end. Going on through, a little bit different from the k-nearest neighbor, since we only have the one feature of P-class. As you can see here, I've included Jack, Rose, myself, and my wife, just to see if we would have survived. Now, hopefully, we should get the same results as we did with the k-nearest neighbor, which kind of is encouraging that two different models resulted in the same outcome. So you can see here, Jack and myself, we did not survive. Many males did not survive the Titanic. And Rose, at the age of 17 in first class, survived, as well as my wife, who was also female, but in third class. Let's just look at the results over here from this model. And you can see here, we get the same outcomes of Jack and myself. We did not survive, while Rose and my wife did survive. All right, so that should be encouraging that two different models arrive at the same outcome. But let's explore a little bit more as to how the decision tree accomplishes this. So as the name implies, it's a series of decisions. So using the scikit-learn library, there is a tree object that can be used that pretty much, explores out, lays out the various decisions that are being made. So you can see here we have feature 0, which is our sex, and there's a decision being made at 0.5. And hopefully you can kind of see that. That kind of makes sense because sex was either 0 or 1. So, using a decision of 0.5 kind of cuts us in half, where, you could go, were you a female or were you a male? On one branch of this, and I'm only going to do this once because obviously this is very hard to kind of read, and you could kind of see the decisions are numerous here. But just to kind of show you how you can interpret this. Feature 1, I believe, was our age. So the computer decided to make a decision based off of this afterwards that decided on 9.5. Not quite sure how the computer got to that, but again, this is the machine learning model going through various scenarios and deciding that this is the best decision to make in order to ultimately decide if somebody survived or not. Again, this is hard to read. Luckily enough, there are some other things we can do. So again, from the tree object that got imported from the scikit-learn model, there's something called export Graphviz, where you can actually provide feature names. So instead of saying that feature 0, feature 1, feature 2, we can actually provide the names of the features. We can also provide, and you can kind of see it here, you see class of 0, class of 0. Let's see if we can see a class of 1 somewhere in there. Class of 1. These classes are our outcome. So instead of it saying class 1, class 0, we can say dead or alive. Now, doing all this will produce, I don't know if this is necessarily better, but it does produce some code that can then be used with other tools. Specifically, what we're going to do, we're going to import another library called Graphviz, which allows us to take this data and actually make it into a picture. So I'm going to take the data, which came from here, which is our model. I want you to see this. So it's our model, choosing our feature names and our class names. So it's not necessarily survived, but we're choosing, what does 0 and 1 mean in the survived column, which is dead and alive. So we're taking all this data and we're going to render it as a picture. Now, I've already ran this. Oops. So is it going to pop up? Normally, if you were to run this, you would get the picture here. But I've already ran it and downloaded the picture. And this is what that same list of features and decisions from the previous step look like in a graphical format. So you can see here we made a decision on sex. And if you are less than 0.5, meaning you are a male, you will end up going down this route on the decision tree. And I'm going to try to zoom out a little bit just to kind of show you the depth of the number of decisions that are being made by this machine learning model. And also the fact that in some situations, you will terminate a lot quicker. So I'm going to try to zoom in on one of these. So depending on your decision here, let's try to zoom in a little bit more. So you could go down this route, go down this route, go down this route, end up right here. So in 4 steps, the computer could determine that you are dead. Let's see if we could find one. Actually, this one's not too bad. So I could go down this path, have this decision, make a decision on the P class, make another decision on age, then make another decision on age, make one last decision on age, and then end up in this category where we are now alive. Now, hopefully you can realize, again, through various computations and probabilities, the computer has been able to decide that this is the series of decisions that need to be made in order to create the most efficient model to predict your target. And the beauty of this is that the library is doing this for you. You're not having to create these decisions on your own, but it is useful to kind of understand how the machine went about making these decisions. All right, so let's go back to our presentation and let's review what we've done. So in this video, we went over the decision tree classification model, which is another classification model similar to the k-nearest neighbor. The difference is, though, that the k-nearest neighbor uses the distance formula to predict similarities between various data points, whereas a decision tree runs the data point through a series of decisions to determine if it's similar to other data points that were produced or introduced as part of the training of the model. So hopefully you're excited that you can now classify things and enjoy.